start, everyone, if you want to join the code lab, just download Android Studios, and it takes so many updates, so many packages to download. So do that now while I'm doing the presentation. Later on, you'll have a station there in the middle. One device is for me, so don't touch that one. Touch the other one, which is free. Plug it into your PC and you can test your code, because it's a hardware IoT code lab. So you will have to have an actual device and not a virtual one on your IDE. So I'm Ahmed Kuhiji. I'm into marketing and I like technology, and I decided to do an Android Things session for GDG Manama. If you need the Wi-Fi, that's the Wi-Fi. Last code for the Wi-Fi. 3, 2, 1. That's it. We're going from the Wi-Fi. So Android is in your phone. Android, there is Wear OS inside of your smartwatch. There's also Android in your TV. There's Android Auto in your car, and now there is Android Things, which is for IoT devices. The reason why they created this is because there were some common pain points that Google has identified. One of which was that the developers spend a lot of time to create the environment for the IoT device and to have the features they need. The second thing was security. It's difficult to manage the security, especially if you're a small company. So with Android Things, we'll see later on how the security is also managed by Google, and you don't have to worry about it. So that's one of the things that maybe a lot of people underappreciate. But if you search IoT botnet attack, you will be shocked at the results you will find. You will see that a lot of baby cameras and these IoT connected devices were neglected, and the security was not done right on it, and they were used to attack other websites, to attack servers, to attack others. So security is an important thing, and it's one of the pain points that Google identified and came up with a solution, which is Android Things. The third thing is scaling the solution. So if you have a hardware, how do you have a low volume or a medium amount of quantity or volume of devices while managing the costs? So now we'll talk about all of these things. So what is Android Things useful for? It's going to be useful for powerful, intelligent devices on the edge that need to be secure. Examples of these cameras, and not just any cameras, could be cameras that do facial recognition. For example, let's see, point of sale devices, vending machines. A vending machine maybe that is also smart and connected to the internet. Security devices. And we'll build one right now, which is like a weather station. Asset tracking, fleet management, all of these things. You can build pretty much everything or anything you want to build on Android Things. And again, it's for powerful devices. It's not for something basic, because it's going to be running full Android, and you can have a lot of features through it. Next thing. So we'll show you how it can go from prototype to production within a few months. And this is a real life example, and I've seen the actual models in Google I/O. So this is actually a prototype that was built by Google and Lenovo for that final product by Lenovo. So they started with this and they finished with this. And this is all running on Android Things. They started with literally Legos and a basic speaker, basic microphone, and a screen similar to the one we have here. And they've iterated on it. And if you want to see the full journey, you can visit the link here, and you'll see the full journey of how they came from here to the end product. And we will go through the components and talk about them. Now, the advantages of having Android Things is the Android SDK and Android Studios. So you have the IDE you're all familiar with as software developers. You will use the same IDE for Android Things. Nothing is different. It will also use a very similar life cycle for the activities. It's again, there is the on create, on destroy, all the things you're familiar with as a software developer is there for the Android Things. Play services are also there. You can use Firebase, you can also use TensorFlow. There's also a TensorFlow Lite version that you can use on device. You can also access the cloud platform by Google. A lot of things are managed by Google when you're doing an IoT device, so the headache is not there. Signed images, basically nobody can load an image that's not signed or, let's say, pre-approved, so that there is no tampering. Verified boot to make sure that it doesn't load a bad image and then fails. Baby rollback, if you push an update to someone, to your customers, and it fails, like the device would start and then restart, It would find out, okay, there's an issue and roll back to the last, let's say, good image. Automatic security updates, so you don't need to push the security updates on your own every time. It's pushed automatically to all the devices, so you don't have to worry about the security update. So basically, Android Things is trying to make you develop your app or software on the IoT device as much as possible and manage as little possible as for things like security and pushing updates, etc. So these are the things that are managed by Google: the framework, the hardware library, the kernel, and these are the things that we will manage as developers, the apps and the user drivers, and we'll talk about these more. So this is a basic, let's say, board that you would use for developing and also for the final production of an Android Things device. These are called SOMs, and it's a way that was developed to reduce the cost. Basically, let's come up with a few ideas now. Give me an idea of an IoT project. Anything. Any IoT project. Any device, you don't need to be in...
I can talk about our project here. So we are building a smart device for the hardware market. So we can put stuff in the trolley, see it,
register it.
Then just print your...
So that's one project.
You can pay without going into the
Cashier. Okay. So self-checkout.
After the system, we can show you the...
Why not? We'll go through that. So that's one project. Another project could be a smart camera that does facial recognition. Another project could be the weather station we're making today. All of these will have one core component, which is all put into this that we'll all need. Processor, RAM, storage, all of these things are required. So what is happening here is that Google has partnered with companies such as Qualcomm, such as MediaTek, such as Intel, to create mass quantities of this component, which all of us will need for all of our projects, so that the cost is driven down. So the cost of having this is lower, because if you were to make your own chip or go to a manufacturer and negotiate with them, the cost would be high. So the idea is you would put this on a developer board or a breakout board and develop on it, and once you're ready to go to production, you could simply change this to another thing. Let's say you're developing on the NXP chip we have here, and then you decide down the line, okay, I need a high resolution screen, I need more features, I need something more powerful. You can switch from this to another chip without changing your code, because Google manages something called BSPs, board support packages, so that they do the translation between your app and between the hardware, so you don't have to deal with them. So let's say that if you need to upgrade the hardware or downgrade it down the line, it doesn't matter. Google manages the BSP, you just write the code. So a closer look at this, the SOM. This is the SoC, it's just the processor and the graphics. The flash, which is the storage, like in your phone you have 128, 256. These will be like 4 GB, 2 GB, small amounts of flash storage on it. Memory, the RAM, and the Wi-Fi and Bluetooth. So these components, again, are things that will be in almost all of the IoT projects we have. And that's why you can buy these at a more affordable cost, because they're being mass produced. Also, testing is done by Google and their partners. So you don't need to do any testing, you don't need to get any licensing for it or anything, it's already all done on this. Okay, let's talk more about the development on Android Things. Displays are completely optional, because a lot of IoT devices, for example, maybe your project will not have a screen on the card. Maybe it does. So it's an optional thing. You can have a display or you don't have a display, it doesn't matter. If you do have a display, it will not show a notification bar. It will not show dialog boxes, because that's more for phones, tablets. And this is an IoT device, so you'll only have your software running without any system UI. Alternative methods to kind of have a user interface is to have voice recognition, for example, and you can use the Google Assistant SDK, and you can have, for example, a joystick. Our one will be a sensor, and you have buttons, but will not do any of the buttons. So this is a traditional stack for Android software. a lot of things here you will notice will not need it in an IoT project. Do we need a launcher? Not really, because it's only one application. There is not many applications to manage. Do we need phone, messaging, contacts, calendar? Not really. Okay. System UI, we said there is no system UI. Your application will have the complete priority. Notifications, that's all gone. So let's remove all of that, and then we'll just add in a few things that we'll actually need, which is the peripheral I/O to connect with the devices through standard APIs such as I2C, I2S, such as GPIO, which we'll talk more about in a minute. And there's also user drivers, which we'll also talk about. So these are the peripheral IOs, GPIO, PWM, I2C, I2S. These things, if you're a hardware developer, you'll know them immediately, okay? But if you're not, it's okay. There are user drivers that are created by other developers, that are created also by Google, and you can just write a piece of software to, for example, turn on an LED or turn off an LED without needing to know the actual hardware APIs. So you can do it both ways. You can be a hardware person that develops and create user drivers for others, or you can be someone that just develops on top of these things. Today we'll be using a user driver actually provided by Google, so we won't have to deal with these low-level APIs. So in summary, you'll have the power of Android. If you know how to develop on Android software, you'll be an IoT guy at the end of the day. I guarantee you. You said you don't know, I'm telling you you know. Because it's exactly the same IDE, same life cycle, nothing major is different. The BSPs are managed by Google again, so you can start from a prototype with this exact board you have here, and then you can shift to something that's ready for production, for producing 100, 1,000, 10,000 units, it doesn't matter. And that's all managed by Google and their partners, so you don't have to worry about it. We'll start today on the NXP chip. Again, you can shift to any chip later on. And it's also automatic and secure. So there is a IoT console for you to push updates to users, for you to manage things from there, and security updates are done automatically. So I'll show you now, this is what we saw at Google I/O, some of the Android Things projects. So this one is actually using Android Things. It has a bunch of servos to control the fingers, and it's using TensorFlow, which is machine learning, to identify what hand gesture you're doing and then play a game with you. So you see here I lost the first game against it. And we have the LEDs here and everything. So it's all done by Android Things. I can't skip forward, so I'll talk about a few other things, and then you'll see a few other projects. So Android Things is now version 1. So you guys are probably one of the first people to see Android Things and develop on it. It's very new, and I think it's a really exciting thing, because if you're a software developer, now you can become an IoT developer. I think I beat it, I'm not sure. Okay, I beat it. Now this is another project. It's a small device, you carry it like this, you take a picture of yourself, and it will change your selfie into this kind of marker image. And a lot of these projects, you can find them online. I'll give you the resource at the end. Some of them you can find the code, some of them you'll see how they've built it, the components and everything, and you can build your own. Again, this is running Android Things. This is another one using TensorFlow. They've taught it the emotions of people and how it looks on their faces. So you stand in front of it, and if you smile, it turns blue. If you frown, it turns yellow. If you're angry, it turns red. And there's a camera here. So for example, there is no screen, right? It's just a camera, and that's the input. I stood in front of it, it's identifying. I was happy, I guess, so it turned yellow. I was angry, it turned red. And it keeps changing in that way. So that's another interesting project that we saw, again using Android Things. I think there's one more. You know Google Home, the assistant, voice-activated one? So this is the exact same thing, but it's printing. So it's just a waste of paper, but it's a demo for us to see. So it's printing your request, so how's the weather, and it's printing the response by the assistant. So it's just showing you that you can convert into an IoT project very quickly. I think that was the last project. There was also a 3D printer using Android Things. And there was one more actually, which is a smart projector that also uses TensorFlow to identify things you draw. Okay, so this is, I think it's called Lantern. It's using TensorFlow to identify things you draw on the paper. So it will request you to draw things and then verify if you've drawn what is requested or not. Okay. So you push the button to start, pick up the marker, and start drawing. So it said draw a house plant. Then you start drawing the house plant. I can't draw very well, I'm sorry. So it says, I see a house plant. So it's identifying it using machine learning, and if you want to see how it saw that, you scan the QR there, and it will show it on your phone. It shows you what you drew. There's some voiceover going on here, but I skip it. Okay, and that's what it saw. I don't know what it saw, but it saw the thing that it asked us to draw. Machine learning, who knows? Okay, so that's the projects we saw over there. Here are final products that were created as part of the Android Things 1.0. One which was by Lenovo. They saw the Lego. You saw the Lego demo. They decided to go with a nicer looking one. And there's an LG one and a JBL one. They're all smart assistant speakers with screens. So it's like a Google Home with a screen. And they're all using the same exact chip. So we talked about the SOM chip. It's all using the same chip. It's the, I forgot its name, Qualcomm SD640. You can check it online. You can buy one if you want. And there are some other chips from MediaTek and other companies that will be rolling out. So these are some additional resources on Android Things in case you want to check them out. There's also a dedicated website for Android Things. Additionally, if you do create a project for Android Things, you can submit it to Google and they might even share it with people. They're very interested in seeing what projects you create. So these are the things. We'll take a short break, maybe 15 minutes for prayer. And then after that, we will start with the code.
Prayers in 3 minutes, just saying.
3 minutes?
Yeah.
3 minutes.
So in the meantime, if they want to download the dependency, anyone that's on meetup.com, I've sent you links. So make sure that you've downloaded if you are following along. If not, you can just watch. It's up to you. But I would utilize that time, the 3 minutes at least, until it's prayer
so
time.
I don't have time to show them a few demos?
You could show them a few demos
Okay,
if you like.
let's show you guys a few demos. Okay. So, I'm running the weather station. You can come closer. It's okay. You can take a look at it. This is the weather station. It's a slightly more advanced version of what we will build today. Okay. This is the developer board with the package. It's called the IMX7D. It's a developer board. It's not meant to be in a final product, but you can shift from this to a chip like we saw on the screen very easily without changing anything in your code. And then you can put it in a final product. This is a starter kit they gave us at I/O. So it includes things like a camera, a screen, Wi-Fi, and this thing, which is called a rainbow hat. It's just for developers. It has a bunch of buttons, and it has LEDs. So if you see, if I'm pressing the button, it's converting, I think, from centigrade to Fahrenheit. And it has two sensors in this thing. One is a temperature sensor to measure the temperature, and it's displaying it here. And there's also a pressure sensor, which is displaying the pressure over here. It says around rain. I don't think it's gonna rain today, unless it's gonna rain inside here. But yeah, it's not meant to be accurate. It's meant just to be for demonstration development purposes. You can do all sorts of things. You can have the display, for example, names or strings or whatever you pass through it. You can have the LEDs change colors. It doesn't need to be pressure and temperature, but today we'll be trying pressure and temperature. Let me load up another one. This is a nicer one. This is a TensorFlow classifier. We were seeing it earlier. So you can put an object in front of it and then press this button Okay, and you noticed it said water bottle. It identified it. And this is using TensorFlow. So they have a model that was trained to identify objects, and it's just using one button to take a picture. The same way you would use the camera on Android for software development, you'd use it here. And there is a code lab for this if you want. This was trained to capture images with a pure white background or a perfect image. So sometimes it will not be accurate. Like it might see something on my shirt and read it incorrectly. If you want to try, we can put another object, but I am not liable for whatever it will say. It will say some really weird things here. Yeah?
Glasses? Okay, glasses.
Glasses? Okay. I don't know what's gonna say, yeah? Let's try and do this. I don't understand. No, I didn't get it.
Barbell.
No. How do I? Angling the camera is probably the most difficult thing. Somebody needs to develop a real-time version of this. No.
Okay, with a keychain.
Okay,
This is some else.
let's get it first. No.
You want to try a white background?
Yeah, we need to put maybe a white background and then hold it.
yeah,
It's trained to do it on perfect situations. It's not done for this. So who's gonna volunteer and hit the button?
Okay.
No, it's not guessing it. It doesn't make your glasses. But there was another one that will identify breeds of dogs. There was another one that will do, like you can train it to do anything you want. Like we saw on the screen, the one that plays a game with you, it was trained to identify the three, scissor, paper, and rock, and you can train it to do whatever you want. So these are a couple of things, and we're going to do the weather station after the break.
Is the board available to buy?
Yes, I believe it's $200 or $250. It's not exactly cheap, but it's something very nice to have, especially if you want to experiment into IoT.